this negative exponent really means divide by that base twice. Instead of dividing by this fraction, I'm going to multiply by the reciprocal. So I'm going to change that negative exponent or divide into a positive exponent, which means times. And I'm going to use a reciprocal. So I'm dividing becomes multiply by the reciprocal. So notice that I'm flipping the fraction. Okay, so I flip the fraction here and I've got this expression. I'm going to work out the powers on the inside. So I'm going to apply power to power here. So I'm going to end up with x to the power negative 6 y squared. I'm going to apply this power to power. This means divide twice. This means divide as well. This divide really means multiply in the denominator. So this is going to end up being positive 6 in the denominator. This becomes negative 15 in the denominator, and don't forget that 2 on the outside. So just going to highlight this here. So what I did was this negative basically allowed me to flip this fraction. Okay, so dividing by a fraction is multiplying by the reciprocal. So here I have power negative 6, power positive 6. These do not cancel out because this means divide. This also means divide, so they really should count together. So what I'm going to do here is I'm going to put that negative in the denominator where it really belongs. So y squared. This becomes x6 times x6. Okay, one of those 6's, power 6's, was already there. The other one comes down from the top as divide. Okay, so those are both divide by x 6 times. This negative 15 is divide. There's my division. It's in the denominator, but it's divide in the denominator. So divide, divide. So really that should go in the numerator as times. Okay, so now I've got my y's and x's together. I have y to the power 17 on top, x to the power 12 on bottom. I'm going to square it. So I get y to the power 17 times y to the power 17. That gives me y to the power 34. And then x to the power 12 times x to the power 12 is going to give me x to the power 24. Or I can just apply the power rule. Power to power, we multiply. So that's one way to do it. And again, there are many different ways this can be done. So I'm just going to show 2 of many. So this one here, let's maybe do inside out again. And I'm just going to keep track of my negative power out here. I'm going to apply my power to power. I'll do the power to power first. So we end up with x to the power. Actually, let's maybe put that in the denominator. Okay, so we have 1. That's a divide in the numerator. So I'm going to put it in the denominator as divide by that base, which is x squared y5. Okay, and what was already in the denominator was, I'm going to apply the exponent in, so I'm going to end up with x negative 6 y squared. And that's all to the negative 2. Okay, just so that we can see where that came from. This was my numerator. It ends up down here. Okay, and I forgot to do my power 3. Okay, and then my denominator piece ends up, I applied the power into the denominator brackets here. Okay, so just make sure I have my counting correct. I'm going to, again, work just on the inside. I'm going to apply this power, so I have 1 over x to the power negative 6, y to the power 15, x to the negative 6, y squared. Again, it's all connected by add, and this is important to reiterate this. I've said this before. If there's any pluses in here, we can apply any exponent properties in here. Exponents and plus and minus just do not mix. Okay, so I'm going to continue with my inside. I'm going to group my x's together. I'm going to end up with x to the negative 12, y to the positive 17. I can apply my power in now. This is a negative power to a negative power, or divide in the divide. So I'm going to end up with 24 in the denominator. And this becomes y to the negative 34 in the denominator. Well, that's a divide in the denominator, so we're going to put y to the power 34 up top, x to the power 24 on bottom, and there's our answer, which is the same as what we would have got down here.